So we will see another problem from tutorial sheet 3. It is example 4.5 from the textbook. So there is a finite sheet which carries charge, and the sheet is given like x is between 0 and 1. So let us see how we can draw this. So let's see, this is z axis, x axis and y axis, and now x is changing from 0 to 1, x is changing from 0 to 1. So this is x is equal to 1, and also y is also changing from 0 to 1. So this is the point y equal to 1, and you see z is given as 0. So it is in the xy plane, and it is having a charge density which is a function of x and y. So this is the charge density which is given, and you see here the unit is nanocoulomb per meter square. You have to find what is the total charge on the sheet. Then you have to find what is the electric field at the point 0, 0, 5. So this is the point 0, 0, 5. X is equal to 0, y is equal to 0, and z equal to 5. Then what will be the force experienced by a charge of minus 1 millicoulomb located at 0, 0, 5. So first of all, we will see the first part. That means the total charge in the system on the sheet. So it is given that the charge density is given by xy into x square plus y square plus 25 whole power 3 by 2. Okay, then it is the unit is nanocoulomb per meter square, and you want to find what is the total charge on the sheet. Now if you want to find the total charge, so the first part, the total charge on the sheet is given as, you have to integrate the surface charge density over the whole area. So the area is actually given as x changes from 0 to 1. So let us consider x is equal to 0 to 1, and also y changes from 0 to 1. Then xy into x square plus y square plus 25 whole power 3 by 2. Okay, then dx dy. Okay, now this much nanocoulomb per meter square, that means this much nanocoulomb. The answer will be in nanocoulomb. After, if you integrate the surface charge density, you will get this much nanocoulomb, because dx dy will give you the area. Okay, now we want to integrate this. How to integrate this one? So that's what we are going to discuss now. So let us consider this x square is equal to t. Then we will get 2x dx is equal to dt. Okay, 2x dx is equal to dt, or we can say x into dx is equal to dt over 2. So we will use this to integrate along x. So we will get q is equal to, we have the variable y is equal to 1, and you see here instead of x, you see x is changing from 0 to 1. So when x is equal to 0, you will get t is equal to x square. That means t equal to 0. When x is equal to 1, you will get t equal to 1. This is because of this relation. Okay, so it is coming from here. So t changes from 0 to 1. Then you have y. Then you have already put t square is equal to x square is equal to t. So t plus y square plus 25 whole power 3 by 2. Then you can see that there is a term like x into dx. So x into dx, we have already seen it is dt over 2. So this become y over 2. Now if we are integrating this, we will get as integral y changes from 0 to 1. Okay, then y over 2, then what is the integral of this t plus y square plus 25? It is nothing but t plus y square plus 25 whole power, okay, 3 by 2 plus 1 divided by 3 by 2 plus 1. Okay, so you will get q is integral y changes from 0 to 1, y over 2, then this become t plus y square plus 25 whole power 3 by 2 plus 1 is nothing but actually 5 over 2, and this also become 5 over 2. So you will get it as this as here you will get as 5 and this become 2. So finally you will be getting this as, you see here, you will get it as integral y varies from 0 to 1. Okay, then this 2 will cancel, so it's clear 2 will cancel, this become 1 over 5. Okay, then y into t plus y square plus 25 whole power 5 over 2. Then I forgot to write, I think I forgot to write dy. Okay, please add here dy also. So dy. Now again we will put the substitution for y square. So now put y square is equal to u. This implies that 2y into dy will be equal to du. So y dy I can replace with du over 2. So we will see this equation, q is equal to, you can see in this equation, so this is with respect to dy. So you can see here y multiplied with dy is there. So with that I will be replacing it with du over 2. Then I have already 1 by 5, so I will write it here 1 by 5. Next is, you see y into dy is I have already replaced, then t plus, okay, then t plus I think I forgot something, I need to put the limit before proceeding. So I will be putting the limit before proceeding this. So let us first put the limit, sorry for this. So we can put our limit here also, we can put the limit, you see I didn't put the limit here, yes, here you can put the limit actually t changes from 0 to 1, and here also the t changes from 0 to 1 and t changes from 0 to 1. So if I put the limit, you will get q as 1 over 5 integral y varies from 0 to 1, then y into, okay, if I put the limit, then t, if t is equal to 0, if t is equal to 1, then I will get it as y into y square plus 25 plus 1 become 26. Okay, then this into dy, okay, into dy minus, then when I put t equal to 0, this become it will be like, yeah, so this become y into y square plus 25 into dy. Okay, so I will be getting two terms like this. Okay, now we can do the integration. So first part, actually we have seen that it is the function of this, above things are the function of y, but you can see there is y square, so this will create a problem in the integration. So I need to substitute y square with u. This implies that 2y into dy is equal to du, or I can say y dy is equal to du over 2. So if I put du over 2 instead of y dy, and also you see when y equal to 0, we will get u equal to 0. When y is equal to 1, so this is regarding the limit, okay, the limit for y, so u will become 1. So we will get the q as, if I substitute this y into dy here and here, if I replace this y into dy with du over 2, there will be 1 by 2, and you can see already there is 1 over 5, so this become 1 over 10. Then integral u changes from 0 to 1, then I will get u plus 26 into du, okay. Then I will get minus u plus 25, okay, u plus 25 into du. So this will be the final result. So I will get like this, okay. Now I can integrate. So this become 1 over 10 multiplied with, what is the integral of this also, I think, yeah, there is 5 over 2. So we need to consider that also. 5 over 2 is there, 5 over 2, sorry, 5 over 2 whole power 5 over 2. Now we can consider this for integration. You see, what will be the integral of this? This will become the first part, the integral of this become u plus 26 whole power 5 over 2 plus 1 divided by 5 over 2 plus 1, okay. Then you have to put the limit 0 to 1, okay, minus, next it become u plus 25 whole power 5 over 2 plus 1 divided by 5 over 2 plus 1, okay. Then you have to put the limit 0 to 1, okay. So this is what we are going to get. Now you will get it as q is equal to 1 over 10, okay. Then 5 over 2 plus 1, it become 7 over 2. So this become 7 over 2. If I put the limit, use this c, u plus 26 whole power 7 over 2, then this becomes 0 to 1 minus, okay, then u plus 25 whole power 7 over 2 divided by 7 over 2, then the limit is from 0 to 1, okay. So q is equal to 1 over 10. Then if I put u as 1, this become 27, okay. So this become 7 over 2. So you will get it as 27 7 over 2, okay, minus 26 7 over 2, okay. Just put the limit, then minus again 7 over 2 is here, then if I put 1, then it's become 26 7 over 2, okay, then minus 25 7 over 2. So you, if you carefully observe this, you can see here that there is, this one is having a bracket, and you can clearly observe that there are two minus 26 7 over 2. So you will get it as 1 by 10, and 7 over 2 is common, so into 7 over 2, then this into 27 whole power 7 over 2. Then you see this is minus and this is also minus, so minus of minus become plus, so plus 25 7 over 2, and there are two 26, so this become minus 2 times 26 7 over 2. So you will get it as 1 over 35, okay, 1 over 35 into, okay, anyway I can directly simplify this. If you calculate this, you will get it as 33.15, and I have told you the unit for this is nanocoulomb, so the final unit will be in nanocoulomb. So this will be the total charge on the sheet. So I hope this part is clear to you. Now we will see the second part. We want to find the electric field. So we want to find the electric field at 0, 0, 5, okay. 0, 0, 5. So before that we will see the problem again. You see here, this is our x and y and z, and let's say this is 0, 0, 5. Okay, now this is my sheet. My sheet was like this. Okay, and let us consider a small area. Let's say it is having some charge dq. Due to this charge, there will be electric field along this direction. Okay, there will be electric field along this direction. So what will be the electric field? So electric field due to this dq can be given as dE. So what is that dE? dE is given as dq by 4 pi epsilon 0. Okay, 4 pi epsilon 0 and the distance vector. Okay, the distance vector between these 2 points. Okay, so the distance vector, how to get it? This point is 0, 0, 5. Okay, and this point you can get it as, what is this point? This point is nothing but x comma y and z equal to 0. So you can get the distance vector as the final point. What is the final point? 0, 0, 5. So 0, 0, 5 minus x comma y comma 0. So this will be my vector. Then this is my vector. This vector divided by the magnitude of this vector. What is the magnitude of this? 0, 0, 5 minus x comma y comma 0. So this is the magnitude whole power 3. Okay, the magnitude whole power 3. So first of all we will calculate what is the vector which is pointing in this direction. So let's say this is r. So this r is already given here. I have already explained this is your r. So let us define this r. 0 minus x is minus x into ax minus y into ay. Okay, then 5 minus 0, that means plus 5 into az. Okay, this is the vector. So what will be the magnitude of this? Magnitude of this will be x square plus y square, because minus x square will be x square. So plus 25 whole power 1 by 2. So what will be the magnitude of r? So what is this? This is magnitude of r whole power 3. So this become x square plus y square plus 25 whole power 3. That means whole power 3 by 2. Okay, so we got the value for r cube and also we got the value for r. Now we can proceed. So we can write my dE as dq divided by 4 pi epsilon 0 into x square plus y square plus 25 whole power 3 by 2, then minus x into ax minus y into ay, then plus 5 into az. Okay, but you know that dq is given as the charge density multiplied with the surface area. Okay, which is equal to, the charge density is already given, x into y into x square plus y square plus 25 whole power 3 by 2. Okay, this multiplied with the area. What is that area? It is nothing but dx dy, because if you consider a small area like this, if you consider something like this, you know that this is dx and this is dy. So the area will be ds will be equal to dx dy. Okay, so you will get it as, okay, so this will be like dx into dy. So we can now find what is the equation for electric field. It is the integral over the whole surface dE, which is given as integral, the surface is nothing but x changes from 0 to 1 and y changes from 0 to 1, as we have seen in the part A. And you know that what is dq? So dq is having this form. We will put this value for dq in this above equation. So dq will be rho s into ds. So what is that? ds. So what is that? Rho s into ds. So rho s into ds, okay, divided by 4 pi epsilon 0 into minus x into ax minus y into ay plus 5 into az divided by x square plus y square plus 25 square plus y square plus 25, okay, whole power 3 by 2. Okay, now this is equal to, the electric field is equal to integral y changes from 0 to 1, integral x changes from 0 to 1. The rho s is given as, we have already seen what is the value of rho s into ds. It is nothing but xy into x square plus y square plus 25 whole power 3 by 2. Okay, then you have ds. So what is that ds? It is nothing but dx dy. Then we have to write our vector minus x into ax minus y into ay plus 5 into az. This 4 pi epsilon 0 into x square plus y square plus 25 whole power 3 by 2. So you can see here these two terms will cancel. So we have only a few terms left. So we can find the electric field as, electric field is equal to integral, okay, we will take this 1 by 4 pi epsilon 0 outside. So 1 by 4 pi epsilon 0, then we can see xy, we can see double integral, x changes from 0 to 1, y changes from 0 to 1, then xy into minus x into ax minus y into ay plus 5, I think, right? Yeah, plus 5 into az, okay, into dx dy. Then yeah, that's it. So the integral become more simple, I think. Integral become more simple. And you know that the charge is actually, the charge density is given in nanocoulomb. So don't forget that. So the charge density is given, this charge density rho s is given in nanocoulomb per meter square. So whatever you are calculating, you have to multiply this with 10 power minus 9. So everywhere you will be multiplying with 10 power minus 9. So you will get it as 10 power minus 9 here also. Now you are actually, now you can proceed. So what you can do to integrate now. So you will get the electric field as 10 power minus 9 divided by 4 pi into, what is epsilon 0? Epsilon 0 is given as 10 power minus 9 divided by 36 pi. Okay. Now this you will get it as, you see here, this is a function of x and y. So you will get the first part, actually if you multiply this, you will get it as x square into y, then minus ax. Okay, so before that I have to put the integral also, that's good. Now integral x changes from 0 to 1 and y changes from 0 to 1. So this become x square y, so minus x square y into ax minus y square x into ay plus xy 5xy into az. Okay, then you have to take over dx dy. So first we will integrate with respect to x. So electric field become, you can cancel out all these terms, this pi, then you see this become 9. So this become 9 times, and I am integrating with respect to x first. Okay, if I integrate with respect to x, and this become minus x cube by 3, okay, minus x cube by 3 into y. So I will just put here minus y, and x cube by 3, x changes from 0 to 1, this into ax. Okay, now minus y square, and what is the integral of x? X square by 2, I can put 0 to 1, then into ay, plus 5y into x square by 2. Okay, x square by 2, which changes from 0 to 1. Okay, now I have just integrated only with respect to x. I have to put my other variable, which is dy. So I have dy also, so I will put it outside the bracket. That's good. So I will put this into dy. So if you substitute this, you will get the electric field as 9 into minus y. Okay, and integral, you see integral y changes from 0 to 1, y changes from 0 to 1, then I can take this as minus y, and 1 cube by 3, that means y cube by is become 1 by 3 into ax minus y square by 2, because 1 minus 0, this become 1, then into ay plus 5y, okay, divided by 2, okay, it's become 1 by 2, then multiplied with dy. Okay, so let's see now. So this will be my electric field. Okay, so my electric field will be like, now E is equal to 9 into, if I integrate this, y varies from 0 to 1, y minus y by 3, that means I will take the integration of minus 1 by 3 into y square by 2. If I integrate with respect to y, I will get y square by 2. Okay, then minus 1 by 2, minus 1 by 2, then multiplied with, I have to integrate y square, then it become y cube by 3, and y changes from 0 to 1, then plus 5 by 2, and integral of y is y square by 2. Okay, then it changes from 0 to 1. Okay, so I hope it is clear. So this is equal to, E is equal to 9 times, okay, then this become 1 by 2, so minus 1 by 6. I forgot to write, I think, ax, ay, az. Okay, I will use a different color. This is ax, ay, az. So minus 1 by 6 into ax minus 1 by 6 into ay, plus, and this will be 5 by 4 into az. So this is my answer. So this is my electric field. So this electric field is having the unit, actually it is volt per meter. Okay, volt per meter. It is because we have already substituted, it is not nanovolt per meter. You see here we have already substitute for the charge density, which is in nanocoulomb per meter square. So we have already considered that nano part here, 10 power minus 9. So next is, what is the force which it acts on the charge which is placed at the same point? Okay, so what is the force experienced by minus 1 microcoulomb? So it's very easy. If you know the electric field, you just multiply it with the charge. So the force experienced on minus 1 millicoulomb is nothing but the charge multiplied with the electric field. So you will get it as minus 1 into 10 power minus 3, okay, multiplied with your electric field. So your electric field, you see this become minus 9 over 6 into ax, minus 9 over 6 into ay, okay, plus 9 5s are 45, 45 by 4 into az. Okay, so this will be the force. This much newtons will be the force acted on it. Okay, you can multiply and find out the answer. I hope it is clear to you. Thank you.